let's start our sharing. So again, welcome to IME webinar. And first of all, as usual, I would like to share our vision and missions to all the attendees here. First of all, our vision is to be the best in class design and manufacturing solution provider. And our mission is to provide innovative design and manufacturing solutions and services to ensure our industries and educational institutes fulfill their design and manufacturing needs faster, better, and in a cost-effective manner. In IME Group of Companies, we provide 360-degree solutions. Start with product design and development solutions, engineering services, scanning and inspections, rapid prototyping, and e-manufacturing solutions. Today's webinar brought to you by IME, and we shall focus on product design and development solutions. These sessions will conduct by our product manager, Sil, and the title is on to predict product defect for industrial machineries. This is the second webinar. The first webinar was conducted last week, which is evaluate product manufacturability for industrial machinery, where I will do a quick recap for today's agenda. I will do a quick recap on our previous webinar. And as I promised to the attendees attended last week, that this week it will be more technical, we will involve more live demonstrations. So I will conduct 4 demonstrations. First of all, assembly static analysis and design optimizations. And then from that, move on, we will conduct the board analysis, which is a very common analysis in industrial machinery. Follow up, understand that you all have the needs to do CAM, using the CAM design, and how SolidWorks motions can help you to define the CAM mechanism in SolidWorks. So I will cover that as well. And last but not least, motion analysis for machines performance study. So let's say if you have a design, you would like to know the power required or the torque or the reaction force, we will use a motion analysis to perform this study. So during the demonstrations, during the presentation, if you have any question, do not hesitate to write it down, because at the end of the agenda, we will have a Q&A sessions, and you are feel free to ask any questions. So let's start our sharing today. First of all, a quick recap on what we did last week. Last week, we focused on the simulations. As we all know, SolidWorks split into 3 types of simulations. We have the finite element analysis, FEA, which is those that we have covered last week. We have computational fluid dynamic, or called the flow simulations. And we have the plastic injection simulations. So last week, we focused on the FEA portions, where we mentioned, we addressed the current design concern. Start with more and more customers asking for analysis reports. It's become very common. They're asking for reports for FEA. Designers have the need to check the performance of the design. Of course, as a designer who continuously challenging yourself to have a better design, you tend to optimize your design for weight and performance. For QA/QC, for the management concern, they would like to improve customer satisfaction by reducing rejects and rework parts. And of course, most of the management level always tell me this statement: I do not have the right expertise to perform FEA. So my answer to them is that why you need to hire when you can easily train your current user to learn it. And today, the demonstrations will be very focused on technical track, where you can see some demonstrations on how SolidWorks simulation act as an additional features in SolidWorks to improve your design. And I show this model that last time we have the CAD and the FEA separated into 2 different modules, but now what we did is that the finite element analysis, FEA, is combined into the CAD as a features, which means when you are designing a parts, if you have the needs to study or to calculate the part stress and deformations, immediately you will do it inside SolidWorks as advanced features, which for you to save time and to save your prototyping costs. And I believe you have seen this model, okay? So what we want to do with this model is that this knuckle here is a new design to improve the previous design. So now what we want to do is that we want to study, is this knuckle design strong enough for these applications of 180,000 Newton. Last week, I have shared quick videos on how we perform the simulations. So this week, I will do a demonstration with the similar parts again. This time, I will go a little bit slow so that for those who have questions, you can just write it down. At the end of the sharing, just ask, okay? Now, you see here, this is the assembly parts of the similar model that I'm showing in my PowerPoint. So first of all, we have the design here in SolidWorks. And when I have the needs, I see that this model, I said, okay, I would like to know if 180,000 Newtons applied onto this knuckle, how will be the deformation? So just go to my simulations and I turn on my study. Now you can see this is all the available simulations features in SolidWorks. Let's start with a static analysis. Yes, the interface is very simple. It's like what you've seen on the left. So the application is very straightforward. We go from top to bottom. First of all, materials. As during the design stage, we have applied all the materials to our part. So there's no concern or no additional issue for us to reselect the material again. So this definitely saving our time a lot. Fixture. So in this case, I will fix this rod over here. And then for this part here, it should be allowed to roll. So I add a roller or slider at this face here and at this face here. So this is my restraint. So of course, the restraint is case to case, depends on your design. Now, next, this knuckle is subject to 180,000 Newtons of load applied to this location here, or this face. So I just go to my external load, just a right click, and you can see that my force features is here. Other than that, you can also apply torque, pressure, gravitational force, centrifugal force, bearing loads, or even temperature effect. So let's say in this case, it's a force. 180,000 apply acting onto this face here. Very straightforward. And I say OK. So we just completed the pre-processing where we just set up our 3D model. We apply the boundary conditions and the external load. SolidWorks comes with auto meshing. Auto mesh means by default the software will recommend acceptable meshings. Of course, for advanced user, if you need to improve the elements or the meshing elements in your design, you can always go to mesh parameters and manually change it. The detail, of course, in the training, we shall cover it. So let's say I use the default meshing, I just hit OK. So the software will perform auto mesh. Okay, I think I messed up with the model. Okay, so if you completely run the meshings, this is how the model looks like. Okay, it will break into a smaller element. Okay, so that's why we call it as a finite element analysis. Now with this result, I just hit run. The software will perform the calculations. Calculation time is subject to the complexity of the model. So in this case, you can see the calculation time is very fast, it's less than 5 seconds, and we have the result. So first of all, we're looking at the stress plot. So if you want to know where is the maximum stress, so this is where the maximum stress apply, okay, which is somewhere inside here, okay, and the minimum stress is at this rod over here. Deformations, if let's say we want to know how much is deformed, we look at the displacement. From here, you can see the maximum displacement is 0.168 mm due to 180,000 Newton. And the deformations go like this. So we support animation so that we can see the deformations of our assembly parts. This is how it's going to deform when 180,000 Newtons apply onto this design. Of course, our concern is to know, so still, is my design safe or not? So well, in this case, very simple. We look at the factor of safety plot. Factor of safety plot means the software will let us know what is the minimum factor of safety of the design. So from this case, the minimum factor of safety is 2.29. The maximums go all the way up to 4,000 something, but of course our concern will be more onto the minimum factor of safety, which is the area in red, which is somewhere around here. So which means now the current design is subject to 180,000 Newton with factor of safety of 2.3. In other words, it will not fail at 180,000 Newton. But anything more than 360,000 Newton, this design might start to crack at this area over here. So this is how the color plot shown us. Okay. So if you have the needs to perform design changes, you can always go back to the model, double click on the features here, let's say this part, and I would like to change the features. Let's say the fillet size. Easily, I can edit, let's say I change to 20 mm. So the model is updated. When I go back to my study, I can just easily go back to my meshing and mesh and run to get a new set of data. So this is the flexibility SolidWorks offered to the designer like us, because like I always said, SolidWorks simulation was made easy for designer. You do not really need to get a PhD or get a specialist to perform this simulation. Okay, so we have a new set of result from here. As you can see, even I changed from 30 mm fillets to 20 mm fillets, the factor of safety, minimum factor of safety, just reduced a little bit from the previous design. So it gives us more options. So as a designer, from here, you get better visualizations on the design, and you can do a lot of assumptions and changes for you to reduce the weight while the design can subject to the current conditions. Generating reports. So I'd like to share with you automatic generation features. Just go to the simulation tab, under the reports. So it will turn on a window. So here you can select what you want to share, what you want to hide. Let's say the connector, just hide it. Let's say the designer is me, Swee Chang Wei. I'm from IME Technology. And our URL is www.imetech. Well, if you want to key in, just fill in. And when I hit publish, okay. So now what happened to my software is that it will automatically print screen and it will generate a final analysis report. So you can see my screen is moving because it's actually doing print screening on each model at different locations. Within a minute, you will see a very professional and very complete report in Microsoft Word. And that's it. You got the report. So all the information that I keyed in just now, IME text and number heart, my web page, my name is in the report. So you can see it very well organized with table contents, what kind of units I'm using, the material properties in detail for all the components, load and fixture, how I fix my parts, how I apply loading, what is the value, and of course, last but not least, the result, the study result, the minimum, the maximums. Okay, so we can see it's a print screen. Of course, just a little bit more effort to put in, write your own conclusions. Or if you have your own report, you can just use the information provided by this report. Just copy and paste into the report that you want to submit. And I believe this is a great time saver for people like us who are not really fancy in doing reporting. So one additional features in SolidWorks. So as I always say, this is a simulation software for designer and engineer. It's very easy to use. It's very interactive between design and validations, and it will definitely help you to understand how to make a better design. Okay, so that's introductions of SolidWorks simulation in SolidWorks. What additional features that industrial machinery need the most? Example like this one here, bracket. Very simple bracket design, but some things that I want you to take note is on the bolt. Every bolt save is every cent we save, right? So of course, as a designer, we would like to use the right amount of bolt, use the right size of bolt, and of course to optimize your design. So which bracket is the best? Oh, but go. We use this for many times, but I believe some of you haven't seen this before. So we have the double web 4 bolts, double web 3 bolts, single web 3 bolts, and single web 4 bolts. So we have 4 different designs. Of course, definitely if I have a choice, I would like to use single web and 3 bolts. Less work, less bolt, and we have the right amount of size of bolt. So at the same time, of course, we do not want to have our design to fail. So in this case, a lot of time as a designer, we have this question in our mind, and we are not sure which is the best design I can choose. So in this case, we use SolidWorks simulation to do the job. I take the 4 hole, 4 bolts, single web as an example. This one here. Now, the study is exactly the same with what I did just now. The only difference here is that now I have defined the bolt connector. You can see on my screen, I have 4 different bolt connectors. And if I edit the definitions, you can see the detail is here. I have selected how the bolt is tied between the brackets and the beam, the head diameter, the normal shank diameter, what kind of materials that I'm using, and the strength data. So of course, a lot of time customers ask me, hey Sil, I have difficulty to collect this information. I understand. SolidWorks understand that. That's why in SolidWorks 2014, the bolt created in SolidWorks can automatically convert as a bolt connector in simulations. In other words, if you are using this whole wizard, if you are using the toolbox and you put in the bolt from the toolbox, when it comes to SolidWorks simulation, it will automatically detect the bolt and convert into a features in SolidWorks simulations, okay, as a bolt connector, which means all the information here will shown automatically by having these functions. So a great time saver, and is to answer a question that how can I get the bolt information. So after you apply the load, setting is exactly the same. We reaching the top and the bottom. The force applied is here, 1,500 Newton. We do the meshing, and at the end, of course, we get the stress result. And in addition, we have one free function here called define paint board check plot. So when I click on this check plot, when I say OK, now the software telling me 4 board is OK to use, which is green in color. Let's say here, I have a calculated factor of safety is 2.5, but the design here is just 2. So maybe I can consider to reduce the size of the board or the amount of board as well. Okay, so 4 board is passed. Now, have a look on another design. Let's say I choose a 3 board design. Okay, 3 hole single web. Just now it's 4 boards. Now we're looking at 3 boards. So if you have a quick check on the board, now you can see all 3 boards is red in color. Need attention. Let's say the first one. The calculated factor of safety is just 1.7, and the required factor of safety is 2, which means if I'm using this design with 3 boards of this size, when I apply 1,500 Newton, the board might tear off, become 2 pieces, which means our design will fail. So this is one of the additional features that can help designer to define the right amount of size of boards and the quantity of the board. So one of the additional features that SolidWorks can offer. Okay, so board analysis. And also part of the sharing today, I go a little bit fast on motion. Okay, we have the time-based and event-based motion, and normally when we use motion, we are not just looking at, hey, how nice was the mechanism. We are talking about doing some calculation, getting some output, for example, power consumptions, the spring and temper, simulate cam drive, or calculate contact force. So this is all the information that we want to know from motion analysis. So take a look on this design here. Now this is a Hamatro, and this is a very common products that are used by firefighting, bomba. So let's say a car accident, they use this to open up the clamp door. Okay. Now I want to study the performance. I would like to know what will be the maximum applied load for these parts to perform under certain scenario. So let's see. Okay. So again, it's very straightforward. It's because we have the 3D model done in SolidWorks. So just spend some time and just loading in the file. Now what happened is that these 2 feeder will open when the actuator pushing all the way out. Now the question is, what will be the applied loads that we need to push this open? And in this case, okay, we put in 20,000 Newton force acting over here and 20,000 Newton force acting over here. In other words, which means this design will need to open up a total of 40,000 Newtons of load, and we need to study what will be the required applied load to make it happen. So straightforward, we use the SolidWorks motion. We define there's an actuator here moving at 60 mm within 10 seconds. Means from 0 to 10 seconds, it will push 60 mm. So this is what we get from the software. Very straightforward. So the maximum applied load happen is the moment when we start contact each other, which is around 2.5 seconds. and it clocked 218,198 Newton. Means 218,000 Newton load is required for us to open, okay, something that's weight 40,000 Newton. Okay. At the same time, you can notice that one of my arm here has some color plot, and we've seen this before, right? Which is in my static analysis. And yes, this is motion plus FEA. So when we're doing the motion study, we would like to study the maximum stretch or the displacement occur onto our arm. So in this case, we can see the result in dynamic. And of course, definitely it will help us to design better product, because at the end of the day, if you look back at the arm, if it's within factor of safety, means it's a good design. But if it's not within a factor of safety, we might need to consider redesign our parts. Okay, so this is SolidWorks motions. And the application is not just limited to opening up parts. I share another very common mechanism which we use in machinery design, cam. Okay, so we have a feature function in SolidWorks where we can actually allow to plot the linear displacement. So we can convert a motion study, okay, or rotating movement into a displacement diagram. It's like what you've seen here. So I have did this sample yesterday night to save our sharing time because we have time constraint. So now what you see here is that this cam will keep rotating and this follower will going up and down. Okay, so let's see. So when the cam is rotating, first of all, we have calculated two paths. One we call, which is this one here, we call the trace path. If you notice, there's a black color line over here. This is the path that we trace for this follower, which means when this cam is rotating, at some point, this follower will like jump up a bit, so over here, which means it's not 100% contacting with our cam over here. Now, if you look, have a look again, right? You can see this area here, it will jump up due to the speed of the cam. Okay, and what will be the movement or the displacement of this follower? We will just refer to this plot number 3 here. We call the linear displacement plot from 0 to 3 seconds. So the maximum displacement will be at 871 mm at 0.8, maybe 85 seconds over here. So from here, once we have the cam designed out by using SolidWorks, we can actually study the displacement by using SolidWorks motions. So this is a very good function, we have very good features for machine designer who use a lot of cam, because recently I got a few customers have some similar inquiry also for machinery. Therefore, I put this out and I share with you all one of the great features that we have in SolidWorks motions. Okay, so that's for today's sharing. I have covered 4 features. First of all, the general final element analysis, and then we look into the board analysis. Instead of showing you weld analysis, I replace it with cam analysis because mechanical parts involve a lot of motions, especially cam mechanism. Or if you are using actuator, you can refer back to my previous demonstrations where I use the actuator to push both arms to lift or to open up a weight of 40,000 Newton. And this all was done inside SolidWorks interface. So designer, you do not need to learn new software or new applications for you to improve your design. So as a summary, what SolidWorks offer for simulation, those in red is the recommended features for you in this industrial machinery. Static analysis, fatigue analysis for warranty, thermal analysis for those who involved in thermal stress. Optimization, definitely everyone needs this one because you want to reduce the weight and improve the performance. Motion analysis, I showed this before. and event-based simulation. This is more to automations when you're using sensor. And if you are designed under a scenario of vibrations or non-linear scenarios, that will have a linear dynamics and non-linear dynamic analysis. In addition, we have the route analysis and the boat analysis for you to use to improve your design. So that's all for today's sharing. And now I open up for, I have another 2 more minutes for Q&A. For you who have any question to ask, feel free to drop your questions on the chat box and I can share with you. So 2 minutes. Any questions, guys? Okay, I see there's a hand raised over here. Let me have a look. Yes? Anyone raise hand? Questions? No, no questions. Or you prefer me to unmute so that you can ask questions instead of typing the questions? Okay, it's okay if you don't have any question to ask. Anyhow, I will drop my email in the chat box. So if you have any questions, feel free to drop an email to me and I will respond to you before Chinese New Year, of course. Okay. So with this, we end our sharing here. And for any technical supports and contact, you can always feel free to contact us via email supports, which is shown here, or telephone assistant, which is 1300-882797. Hi. Yeah, I think someone asking me questions. You can feel free to drop your questions in. Yeah, we even provide remote access for your information by using this technology. So let's say if you have any support issue, I can always remote control your computer from my place. Okay, the question is, how do we simulate the area near to the boat? Mr. Ang, for your questions, right? When you want to simulate the area near to the boat, normally we will use the normal static analysis and we apply the loads, or we apply the boat as a connector. So the apply load from the connector will actually effect onto your model as well. So just a simple static analysis can do that. Well, the surface depends on the apply locations. Oh, no. No. We just select the edge of, okay, I'll show you through my screen. So now you can see here, this is the area where we apply the boats. So the boat connector, we will select the edge. The edge over here, now you can see the first edge is the boat head hole, which means the boat head will be at here. And then here we have the boat nut hole. Here is where we put in the nuts. So we just need to choose the edge. Okay, so the first edge again is the boat head, and the second edge is the boat nut. So from here the software will know that the boat will put in from here all the way in, and the nut will tighten inside. And the diameter for the head and the nominal shank, we just key in here, or you can use the 2014 features where it will automatically apply into your FEA analysis. Do I answer your questions? Okie dokie. Good. That I answer your questions. Okay. If you have more questions, you can feel free to ask. No worry. So for your information, our SolidWorks support is 100% certified expert, and we are ready to provide a live technical support. Yes, you may ask your questions. Yes, you can study friction as well. You can study friction analysis. Let me see, do I have any contact set? Now you see there's properties here, frictions. Okay, if two parts, they are contacting each other. Okay, let's say this face with this face, we can always define the friction value. Okay, so SolidWorks do support friction. Do I answer questions? Okay, good. Okay, thank you. It's great that someone responds to me. I always expecting great questions from customer, and today I think I have some very good questions. So I hope my answer helped you improving the way you use SolidWorks with SolidWorks simulations. So at the end of the sharing, when you say close, they will jump you to a survey. So please feel free to answer most of the survey questions, because your feedback is very important for us to further improve our webinar. With this, again, thank you very much, and looking forward to see you all again in coming webinar, or maybe you can join our hands-on session where our marketing will forward an email to you as soon as possible. So I wish you all happy Chinese New Year and enjoy the rest of the day. Bye.